Okay, we move on to the relationship between position, velocity, acceleration, these important quantities. So using this rotating table, we can model x as a cosine theta. That would be x from trigonometry, and theta equals omega t. Theta from our study of rotational motion is omega t. Therefore, x equals a cosine omega t. And omega is equal to the change in the angle divided by the change in time. This is the angular frequency. And this is equal to 2 pi over t, because each cycle has 2 pi radians, and the time, the elapsed time, is 1 period. So omega also is equal to 2 pi over t. And 1 over t is the frequency f, so omega equals 2 pi f. These are identical values for omega. So we may write x as a cosine omega t or a cosine 2 pi f t. A cosine 2 pi f t. So here we see this sinusoidal function representing the motion very nicely. The maximum displacement is a, the amplitude. And here, this is half a period. This is a full period. This is a 3/2 period, okay? And the motion continues. For the velocity, it is minus omega a sine omega t. And for the acceleration, it is minus omega squared a cosine omega t. Okay? This is how we derive these equations. So we start with this value for x, and recall what we learned earlier for v. If you substitute this for x and factor out a and use this identity, 1 minus cosine squared is sine squared, then v is minus a omega sine 2 pi f t. Okay, so the position is represented by a cosine function, the velocity is represented by a sine function, and there is a phase difference. You have minus sine. A phase difference means when x is 0, the velocity is maximum. When x is 0, the velocity is maximum, as explained earlier. When x is 0, the energy is all kinetic, no potential. So v is maximum. On the other hand, when x here is a, the amplitude, the energy is all potential, and the kinetic is 0. So the velocity is 0. So now we understand this phase difference between the velocity vector and the displacement vector. Okay. Then for the acceleration, if that is x, we know that acceleration is minus k over mx, and k over m is omega squared, because omega is square root k over m, as you recall. So the acceleration is minus a omega squared cosine 2 pi f t. And we understand this minus sign, it is opposite to x. A is opposite to x. This is another experiment, another setup that we may use also to model the harmonic motion, the periodic motion. Imagine this rotating paper. Imagine a pin attached to this mass. As the mass moves up and down and this paper rolls, then it will leave a trace. The trace will be a sinusoidal wave. Okay, so we may model it by a sinusoidal wave like this, or by the turning table like this. All these motions are periodic, are harmonic repeats, and they follow the same equations. Okay, now check your understanding. If the amplitude of a system moving in simple harmonic motion is doubled, which of the following quantities does not change? Total energy, maximum speed, maximum acceleration, the period.
I think it would be the maximum speed.
It is the period.
Yeah. Okay.
Yeah, thank you. So the period of oscillation does not alter the amplitude.